my channel, and we're continuing on in chapter 4 talking about force and simple machines. We're on page 78 and this is going to go to page 81. We're going to talk about our very first simple machine called the lever. Obviously you can see our title here, and you probably notice that the V is upside down, and that's done for a purpose, and I'll explain why later on. So we're going to talk about levers. So there's some vocabulary words I want you to pay attention to. The first word, machine. Second word, effort. Third, load. Fourth, of course, lever, what we're talking about today. And then fulcrum, the fulcrum, all right? Now with each of these simple machines, there's a few things that are going to be in common with each one of these simple machines. With each one of these simple machines, you're going to have an effort and a load. An effort and a load, and I'll explain what those words mean. And also, there's this sentence here on my board. It says, greater distance, less effort. And that's something I want you to memorize in this chapter, because all of the simple machines use this idea. Okay, so greater distance, less effort. Now, I'm going to try something a little new today with this video clip, and it may be a little choppy, but I'm going to, in certain parts of this lesson, I'm going to break off into a different video clip, and you'll see that my head will be cut off, and I apologize for that, but I'm going to demonstrate a few levers for you so you can have an understanding. Okay, so let's get right into our lesson on page 78, and as we read, I will explain to you. Every day you use many kinds of machines. A machine is any object that makes work easier. Some machines, such as cars, are complex or difficult. They are made of many smaller, simple machines that work together. A simple machine may have only one moving part, or it may have several moving parts. The basic simple machines are the lever, wheel and axle, pulley, inclined plane, screw, and wedge. These machines make tasks or jobs or work easier. They do not always reduce the amount of force needed to do work. However, they may change the direction of the force. So let's stop there just for a second. That says the word machine. So that's something you might want to highlight in your book. A machine is any object that makes work easier. For instance, this pen can be classified as a simple machine or some type of machine. While you're putting force, you're writing with it, you're pushing the pen along your paper, you're using a force, and this pen makes writing so much easier. You think about many years ago, they would have to use an inkwell and a feather and dip it in the ink and then write, and it wasn't always the clearest, but now with this or a pencil, this object makes writing a lot easier. Even one step further, today using a computer, things are much faster and easier to write a letter or to write an essay because of the use of a computer. So the computer is classified as a machine, of course. And it mentions in here some machines are very simple. Like this pen, there's a couple of working parts in here. You can push down this button to be able to write, and then you click this button to put the thing back inside. And then there's a spring in here that allows the pen to work. So there's sometimes many parts to a machine, and then sometimes there's just one part. And we'll talk about that in a little bit later. But with all machines, you're going to have an effort and a load, and we'll talk about that in the next paragraph. But something that else I want you to highlight in your book, and something very important about all machines, that they either make the effort or the force less that is needed, the force that is needed, to move an object, the effort, sometimes it reduces that, or it changes the direction of the force. And something we learned in last lesson, there are always two forces that we experience every day, and that is gravity and friction, and both are very important. Okay, so sometimes a simple machine will just change the direction of the force. Instead of working against gravity, you're working with gravity. And so, yes, that makes the work easier. So let's continue on. All machines need a force to do their jobs. The force that you apply to cause a simple machine to do work is called the effort. So for instance, if you are, like in the last lesson, if you're pulling a wagon, you are using that force, you're pulling it forward. You are using what we call the effort, an effort. When you push a shopping cart, you may apply effort so the wheels can move the cart. There are also forces working against the object's ability to move. So when you use force, you're trying to get that object to move, okay? However, sometimes there are forces that doesn't make that effort easy. For instance, pulling that wagon with all those children, you have two forces working against you. You have gravity, okay, and you have that friction. So it doesn't make pulling that wagon very easy. So the more mass you have in that wagon, the more force you need to pull it, all right? And so what you are pulling, that is the load. All right, so let's review that. So effort is the force you're using, the push or pull. The load is what you are pulling, okay? So let's keep going. Gravity pulls an object and gives it weight. The weight of the object being moved is called the load. The groceries in the shopping cart are a load. The weight of the groceries makes the cart harder to move. So maybe you've gone shopping with mom or dad and you're pushing the cart to collect the different items that you need to buy. So when you are pushing that object, what are you doing? You're using effort. What are you pushing? What are you pulling? The cart. Now, remember, greater the mass, greater the force you need, or greater the effort. So as you're putting items into that cart, more mass, more mass, more mass, and you need more force to push it. Maybe sometimes mom will have you help her push that because maybe sometimes the cart gets way too heavy. You just use more force, okay? So more mass, more force equals more work. All right, so let's talk about the lever on page 79. Suppose you're helping a plant to plant a new flower bed or a flower garden in a local park. Before you can plant any flowers, though, you must remove all the rocks that have been dug up. Most of the rocks you can pick up easily. However, there's one rock you cannot move no matter how hard you try. Someone suggests using a long board. You place one end of the board under the edge of the rock and rest the middle of the board on a smaller rock. When you push down on the other end of the board, the large rock starts to move, but you still can't get it to roll. You try putting the smaller rock closer to the larger rock. Now, when you push down on the end of the board, the rock starts to roll. In this example, the board and smaller rock acted as a simple machine called a lever. A lever is a bar that turns on a point. The point is called the fulcrum. The fulcrum was the smaller rock. The larger rock that you moved was the load, and your push on the board was the effort. Remember, all simple machines have an effort and a load. The more distance there is between the effort and the fulcrum, the less effort is required to move the load. So remember, this is where that sentence comes in. Greater distance, less effort. Okay? So it talks about the three parts of a lever. What are those three parts? We have the effort, you pushing, or the force being used. We have the fulcrum. That's the middle. That's the point where the bar is turning, or that lever. And then we have the effort. We have the load. What are we moving? Okay, what are we moving? So in this case, if you look at your picture here, you can see down at the bottom, maybe I can get a little closer and I will demonstrate for you. All right, so here we have using what we call a first class lever, and I'll explain the difference between these different kinds of levers. There are three of them, but we're going to focus on the first class lever. That's the one that's easiest to remember. So here, this boy is trying to move the larger rock. So what is the larger rock called? That is called the load. all right? But he's having a hard time. You see, he's sweating more. He's using more effort. Well, what do we need to do? We need to have greater distance, okay? We need to use greater distance. So we have effort. We have the effort and we have the fulcrum. See what the fulcrum is? It's in the middle. It's closer to the effort. So what do we need to do? We need to create a greater distance between the effort and the fulcrum. So what does the boy do? He puts the fulcrum closer to the load. So what do we have now? A greater distance. So now when he pushes down on the effort, or this side of the lever, he's not using as much force. Okay, it's much easier for that rock to move and it will begin to roll. But if that fulcrum is closer to the effort, he needs to use more force. Okay, and whenever we're doing any kind of work, we want to try to reduce the force or the effort as much as possible. Okay, let's continue on. And like I said, there are 3 different kinds of levers. We have a first-class lever, second-class lever, and third-class lever. With the second-class and the third-class lever, we're going to break to another video clip and then to explain or give you an example of those levers. So let's read about it on page 80. There are different kinds of levers. The board was being used as a first-class lever. This lever has the fulcrum between the effort and the load. Between the load and the effort. Many everyday tools we use the same kind of lever. A paint can opener, a crowbar, and the claws on some hammers are all kinds of examples, common examples. For instance, this is a good one. Like if you have a hammer, and there's a picture of it in your book, right up here. So if you trying to open a can, or sometimes maybe use a screwdriver to open a can of paint, you put that thing under there, and what are we pushing? The effort. So here's the effort. Where is it turning? On the can. What are we pushing out? The load, the lid. Okay, so in this case, either a hammer or a screwdriver can be used as a first-class lever. Let's keep going. Oh, before we move on, you see my picture here? Here's the V, it's upside down. And here, this is an example of a first-class lever. What does that look like? Well, I drew a picture of it down here. This is, we think of a seesaw. That's also a first-class lever. Now here, you have 2 children on the end, and they're equal, they're balanced, or they're at rest. We learned that in the last lesson. Whenever the forces are equal, they're balanced, or there's no greater force on either side. So they're going to balance, okay, or to be the same. Well, what if I made this guy a little bit smaller? Okay? He's just a little guy. Okay? What would happen in this case? Well, this dude, he would push down. Why? Because it's not balanced. Uh-oh. What do we need to do to balance it then? Okay? We need to push the effort further away from the fulcrum. So what needs to happen? Okay? Well, we can do 2 things. Either we can push him out as far as he can go, or we can push him in the middle, okay? And when we do that, it's less effort for him to push this down, okay? All right, so this is an example of a first-class lever. All right, let's move on. A wheelbarrow and nutcracker are second-class levers. For a second-class lever, the effort, load, and fulcrum are arranged differently. Now, remember, they all have the same 3 parts, but they're just mixed around in these different kinds of levers. The load is between the fulcrum and the effort, so that's something you want to highlight for a second-class lever. You use this lever every time you open a door. The door is the load, and you're pulling the door is the effort. The fulcrum is the hinge. Now, I'm going to break to another video clip to show you that example. In this little video clip, I'm going to show you an example of a second-class lever. Now remember, a second-class lever, and I know you can't see the top of my head, that's okay, because I'm just showing you the door. The second-class lever, when we talk about the parts, remember you have a fulcrum, load, and the effort. The fulcrum is where the lever turns. The load is what we're carrying. And the effort is the force that you're using to move whatever load that you're doing. So a door is an example of a second-class lever. For instance, here we grab the handle, okay? And what we're pulling, that is the effort, okay? So we're pulling on the effort. Now, where is the load? What are we pulling? Well, if you said the door, that's correct. So my effort is here at the doorknob. I'm pulling. What am I pulling? The door. Okay? And then where is it turning? Where is the fulcrum? Where's the point at which the door is turning? Well, if you said so right here at the hinge, that is correct. So this is the fulcrum, the door is the load, and where I'm pulling, that is the effort. So that's an example of a second-class lever. A second-class lever, the load is between the fulcrum and the effort. And so let's continue on. Some levers have the effort between the fulcrum and the load. A lever like this is a third-class lever. Okay. Third-class levers use effort to move the lever a small distance near the fulcrum. This causes the lever to move a much larger distance at the load. There are many ways you can use this kind of lever. When you sweep, you put effort next to the fulcrum, near the top of the broom. At the bottom, the broom travels a great distance. Other examples of third-class lever are a fishing pole and a hammer used to pound in a nail. So you can use a hammer for a first-class lever or a third-class lever. Some tools use two levers together to make work easier. Scissors, tweezers, and pliers are examples of tools that made of two levers. So this picture in here, this is an example of a third-class lever. It's a fishing pole. In this case, what is turning? Right here at your wrist. Okay, that would be the fulcrum. Where is the effort? Your hand doing the force. And where is the load? Well, that's the top of the fishing pole. So it's moving like this. Okay, so fulcrum, effort, load. The effort is between the fulcrum and the load. So we'll jump to the clip, and I'll give you that example of a third-class lever. In this clip, I'm going to show you an example of a third-class lever, and I do apologize for you not being able to see my head. It's okay. But what is this object? Of course, it's a broom, but it's classified as a third-class lever. And when we talk about a third-class lever, the effort is now between the fulcrum and the load. Each one of these parts takes a turn being in the middle. So as you're using a broom, your hand up here, this is where it is turning, okay? So wherever it's turning, that's the fulcrum. Now, what is pushing it? What is the effort being used? Well, that's right here, and you're using the other hand to push the broom all over the place to get the dirt. Now, what are we pushing? What is being pushed? That's down here. That is the load. So in a third-class lever, we have the fulcrum up here, the point at where it's turning, the effort that is doing the force, and then what are we pushing? The load, which is down at the bottom. So this is an example of a third-class lever. Remember, a third-class lever, the effort is between the fulcrum and the load. Now, your homework that you can be doing is page 81, the 2 questions, and then in your activity manual 63 and 64, that will help you review for what we just learned. And something else, a little project that you can be doing is on page, I apologize, let's get that, is on page 61 and 62 of your activity manual. Go ahead and read that, and let's see if you can design your own machine using a combination of simple machines, okay? And then sketch a diagram of it, and see if you can help the poor dog in here who is hungry in this activity. I'll see you next time.